2012 question 10a, we have Newton's law of cooling states that the rate of cooling of a body is proportional to the difference between the temperature of a body and the temperature of its surroundings. If theta is the difference between the temperature of the body and the surroundings, we have d theta dt is equal to minus k theta. I'm going to change this to dx dt just to keep it consistent to what we're used to using. Minus kx, just let theta equal x, and we'll come back to it at the end of the question. And it says a body cools from 80 to 60, and this happens in 10 minutes. The temperature of the surroundings is maintained at 20, so therefore the body will be looking at 20 less than these bands. It's kind of a trick within this question. We'll be looking between 40 and 60. I suppose the mistake could be between 80 and 60. That's not correct. It's this one here. Because if a body is 80 and the surroundings are maintained at 20, the difference is 60. And similarly, the difference between 60 and 20 is 40. So be careful if a question like this comes up. So we have the x dt, just because I don't write right in theta, is equal to minus kx. So we're going to get dx over x. It's going to have natural logs here, is equal to minus k dt. And we're going to integrate these. Starting, it's going down, so 60 and 40. And we have, we're just looking for time, we're looking for k here, between 0 and t. So just coming up here, we're going to get the natural log of x between 40 and 60 will be equal to minus kt. Have we got time here? We're told in 10 minutes, so we're actually integrating between 0 and 10. Just change that. So we're going to get the natural log of 40 minus the natural log of 60 is equal to minus, putting 10 in for t, minus 10k. So multiplying by the minus, we'll get 10k is equal to the natural log of 60 minus the natural log of 40. So 10k is equal to the natural log of 60 over 40. So k is equal to a tenth of that, so 1 over 10 times the natural log of 60 over 40, giving k to be 0.0405. How many decimals are we asked for? It doesn't say, so we give it as that. And then we're asked for the temperature of the body after a further 15 minutes. So starting at 10 minutes. So further 15, we're looking for temperature, so it's starting at 40. So then it's going to go to 40 minus whatever. This is what we don't know what this is going to be, so this is going to be our x minus 20. I don't think we can do anything else with that. And we're going to integrate that with respect to time, 15 minutes. So let's see, does that make any sense? So we're going to integrate 1 over x dx between 40 and x minus 20. If we can get a new temperature here, we're going to integrate time between 0 and t, and we have minus k dt. So 0 and 15, sorry. So the left hand side becomes the natural log of x between x minus 20 and x equal to minus kt. I know you can do this quicker. I'm just doing each step as it comes. So the natural log of x minus 20 to find this new temperature minus the natural log of x is equal to minus 15k. We have k, we put it in at the end. So we're going to get multiplying by minus 15k is equal to the natural log of x minus the natural log of x minus 20. So really setting up this integral here, I think, is the key to it. So we're going to get 15k is equal to the natural log of x over x minus 20. We started at 40, so that's our x. So we're going to get 15k is equal to the natural log of 40 over x minus 20. These x's are obviously at the top and bottom end of the bands. So e to the power of 15k will be equal to 40 over x minus 20. Now we want x, so let's just invert these fractions. So we're going to get x minus 20 over 40 is equal to 1 over e to the power of 15k. X minus, well, I'll just multiply this out the long way. X times e to the power of 15k minus 20 times e to the power of 15k is equal to 40. So x times e to the power of 15k is equal to 40 plus 20 e to the power of 15k. Dividing by 15 e to the power of 15k, we get x is equal to 40 over e to the power of 15k plus 20. And factoring out the 20, we get x to be 20 times 2e to the power of minus 15k, if you want to run like that, plus 1. And the k disappeared. So I've got my calculator, it's giving me 41.78. I think I have to temperature the surroundings maybe involved here. That's the whole thing involved. Take off the temperature, the surroundings, get the temperature. X will be 21.78.